Let's start with this geological map. Okay, today we will learn how to plot beds, dates, all these attributes of geological maps along the section line. Before going to the drawing part, okay, from a geological map we can get three kinds of information. First thing is landform. From the contour value, we can get information about the landform and the information about the surface runoff. Surface runoff. Surface runoff. Okay, from the contour value, we can get the information about the landform and the surface runoff. And second thing is that from the geological map, we can get the information about the alignment of beds. Alignments of beds. Okay, alignments of rock beds. Okay, and with the particular deep inclination, all these things. Basically, from a geological map, we can get the information about the outer surface in the terms of landform and surface runoff, and the alignment of the beds, that is the internal information about the area concerned. Okay, from these two things we can easily derive the relationship. Okay, relationship in between the landform and surface runoff with the alignment of beds. Rather, from the geological map, we can identify a relationship in between the internal and outer surface of the earth, outer part of the surface. Okay, we can identify the relationship in between the internal part of the area concerned, internal beds alignment, internal layers alignment, deep, thickness, all these things, and as well as the superficial information, that is landform and the surface runoff. Ultimately, that kind of relationship, that kind of information ultimately provides information about the landscape history, about the landscape history, rather that kind of relationship helps to get information about the evolutionary history of landscape. Okay, evolutionary history of landscape. So from that point of view, the evolutionary history of landscape, from that point of view, the geological map is very important attributes of the study. Okay, straightforward, go to the geological map. How we will plot beds, deeps, all these things in a geological map. This is a geological map. Okay, this is a very simple geological map. It's a map of a fold region. How we will identify in a very simple way and naked eyes, it's a map of fold region. Normally, repetition of beds, that is bed names F, E, here F, E, D, O, and here also a O beds. This is P beds, here also the P beds. The repetition of beds normally shows that it's a map of a folded region. This is very simple way to identify whether it is a folded region or not. Basic concept to identify the geological map is a folded region or not. Basic thing is the repetition of beds. Okay, here beds F bed, here is also the F beds, here in left hand side it is a E beds, here also the E beds. This information shows that this is an area of a map of a folded region. So first thing is that you have to identify the section line. Okay, all the geological map and all the information derived from the geological map mainly based on the section line. All the information we can get from the geological maps basically follow the section line. This is A and this is B. Suppose this is the section line. we can plot all these things, all the information about geological map in the along the section line. So here I took a graph paper. I take it, this is a simply graph paper of inch. Why I am taking the inch graph paper? Because here the scale of a geological map is just merged with the inch graph paper, because it's 1000 feet is equal to 1 inch. So it is easy to plot, convenient to plot. That's why I am taking inch graph paper plotting this geological map. Okay, so first thing is that what we will do, first take a inch graph paper, or you can do in a plain paper too. Okay, and just fold the geological map along the section line. Okay, and just fold a map along the section line. Okay, then place it in a graph paper and just draw the identical line of a section line in your graph paper. Draw with the help of scale. Just draw a line which is just identical of the section line, just identical line of your section line. Okay, suppose I draw this line. I'm trying to do this. Okay, this is a straight line, just identical line. This is the point A and this is the point B. Okay, this is A and this is B. This line is identical to the section line, and this is 1 inch, that is 1000 feet. 1000 feet. Okay, 15 feet, so on. Okay, and here also you can draw the vertical scale according to the map scale. Okay, first thing you have to draw, all have to follow the principle, follow the alignment of contour. Okay, just put your map in a section line with the graph paper and take a scale, and with the help of pencil just plot the contour information. Here the contour information is 1100 feet, so you can easily plot it. That is contour value of 1000 feet. This is the contour value of 900 feet. This is the contour value of 800 feet. This is the contour value. This graph paper helps you to identify very easily the particular point, and very perfectly you can plot all these things. This is 600 feet. This is 500 feet, so on, and just connect all this point with the free hand. This is 600 feet. This is also the 600 feet. Sorry, this is 600 feet, and this is 700 feet. This is 800 feet. That is 900 feet. That is also the 800 feet. Just connect all those points with the freehand. With the help of a normal scale and within the help of a normal inch graph paper, you can easily plot the profile line. First thing that is that here I am getting the information about the first thing is that the surface landform, superficial attribute, that is the landform. This is the landform. Okay. Now come to the point of plottings of the beds. Okay, minutely observe the geological map. We will follow only the alignment of beds and alignments of contour along the only through the section line. Here, start from the left hand side, from the A point. This is our section line. This is beds, one of the beds, that, and this is the beds S. Here the beds S and this beds contours as well as the beds both are in parallel position. Beds and contour never intersect each others. Rather, beds and contour are running parallels to the each others. That means those are the horizontal beds. So these beds and these beds both are the horizontal beds. Okay, very easy to plot horizontal bed. First we have to plot the horizontal bed. So take this graph paper and place your section line with the graph paper, and with the help of scale you have to identify the points of two beds in the topography, this one and this one. Those are the horizontal bed. It is very easy to plot horizontal beds. Just do this in that way. This is horizontal bed and this one is the horizontal bed. Okay, and go through the geological map. Okay, and now come to this segment. Okay, this is a point of unconformity. This is a triple point junction. This is the point of unconformity. This is also the point of unconformity. Looks to this. Those are the triple point junction. Three beds meets in that points. Sorry. So you have to connect all those. You have to connect this. Connects the points of unconformity, and this is the line of unconformity. This is the one line of unconformity. Okay, and observe minutely. Go through the map. Okay, and this is also the triple point junction. Okay, this is also the point of triple point junction. So this is also the line of unconformity. This is also the triple point junction. This is also the line of unconformity. Okay, and next thing is that go through that direction. This is also the triple point junction. So this line, this is also the triple point junction. This is another line of unconformity. Okay, so first thing is that you have plotted those two beds, this one and this one. Those are the horizontal beds. Okay, now come to think about that beds. That's bed number. Most probably bed name of the bed is okay, and not given. Okay, this bed. So think about these beds and go for the strike line for identification of the dip of the bed. This is also the point. This is another point of unconformity, and this is another point of unconformity. In between two unconformity, two consecutive points of unconformity, there is in beds. So you have to identify the dip of this particular beds. For that purpose, you have to go for the section line. You have to draw the section line. Okay, suppose think about that. Okay, suppose this point and this points, this is the contour value of 900. Just draw the section line. This is the section line of 900 feet, and draw another parallel line to this strike line of 900 feet. Here the same beds, this is the upper boundary of this beds, cuts by the line of 800 feet. With the help of set square, you can draw the another strike line. Then what will be the direction of the depth? The deep direction of the dip will be higher value to lower value. If you pour water moves from the higher value to lower value equally. The deep direction is that kind. So for that particular bed, that single bed, the deep direction and deep amount is 800 to 500 feet. This point is the point of 800 feet. This is the point of this is the point of 900 feet. This is the point of 800 feet. So for go through the geological map of your map. Go to the geological map to plot this value. Okay, you have plotted two horizontal bed, and these two horizontal bed, after this there is a line of unconformity. Conventionally, line of unconformity shows in with the help of red color. So I have plotted these things in red color. So take this measurement. Okay, this is just, you can, with the help of compass, you can draw another straight line. You can draw another straight line. Okay, and with the help of compass, This is the point of 900 feet. Okay, this is the value of strike line is 900 feet. This is the value of strike line of 800 feet. So this is 900 feet, this is 900 feet, this is 800 feet. Okay, therefore you have to plot the angle or plot the diff. This is 900, obviously that point will be 900. So this is the first, this is the first angle. So we have to plot this angle within the section line. So go through this and plot the map, put your map in the section line, and just you have plotted the two horizontal bed, third one is that point. So take this vertical distance, and with the help of set square, you have to plot this one. Okay, this one. Now go through the map, go through the geological map. Okay, so I have plotted this third, I have plotted this one and this one, those are the horizontal beds, and I have now I have plotted the third beds with a very slight angle. Okay, now come to the beds of G, F, E. Okay, for that purpose, go through the strike line. We have to draw the strike line. Okay, suppose these are the contour of 600 feet. So draw another strike line. This is the value of 600 feet. Okay, draw another parallels with the help of set square. With the help of set square, you have to move slowly and draw the another strike line. This is the value of 600 feet. This is the value of 700 feet. So obviously deep will be 700 to 600. Okay, so for plotting these beds G, F, E, we have to follow the angle, this second angle. This is the first angle, this one is the second angle. Okay, just fold your map and place it in here. With the help of compass you can do it. Okay, here this is the value of 700, this is the value of 700, this is the value of 600. Okay, this is the value of 700, this is 600. Obviously the deep will be okay. So we have to, this is the second one. So with the help of geological map, we have to identify the locational point of the beds with the help of the scale. This is E bed, upper boundary of E bed. This is the upper boundary of E bed. This is the upper boundary of G bed. Just plot these three. Okay, with the help of set square, or two set square or a scalar set square. This is one bed, this is another beds, and this is third bed. Okay, so go through the map. Okay, go through the map. Okay, go through this geological map. So I have plotted these two horizontal beds, and these beds just in the sandwich position of two consecutive line of unconformity. And again I have plotted 1, 2, 3 beds. Okay, 1, 2, 3 beds. So this is also the line of unconformity. So here I have plotted 1, 2, 3 beds, and 1, 2 and 3 beds, 6 beds. Okay, just follow the section line. 1 bed, 2 beds, line of unconformity, 1 beds, line of unconformity, 1, 2, 3 beds. So I have plotted 6 beds with 2 unconformity, like 2 lines of unconformities. Okay, to go to the right hand side of the map. Okay, just think about these beds. This is another line of unconformity. So first, before plotting the line of unconformity, we have to identify the deep of this one and this one. Okay, go through the section line, go through the strike line, and suppose this is the contour value of 600 feet. So join the line of 600 feet. This is 600 feet. Okay, this is the 600 feet. Okay, with the help of 4 set square, draw a parallel line of that. This is the contour value of 700 feet. Okay, this is the contour value of 700 feet. Obviously, deep will be 700 to 600. So the deep of this beds and this beds is in that direction. Okay. Now think about before plotting this beds. Think about the beds above the line of unconformity within this zone, within the zone of within this zone. Okay, here this is the contour of 800 feet cut in that point, and this contour cut in this point. Okay, so you can join the points. Okay, you can join the points, this one and this one. You can join the points. You can join the points. You can join the points. Okay, with the help of purple color, with the help of this one, with the help of, so I am doing this strike line. This strike line cut the section line outside of the map area. It may be inside of the map area, it may be in the outside of the map area. This unit cut in that zone, and another parallel lines, that is cutting the cutting the contour of P, that is 800 feet, and that is 900 feet. Obviously direction is 900 to 800. So before plotting these beds, we have to first plot the beds of P and O, and direction deep of the P and O is from that point to this point. Okay, here the section line cuts the here the strike line cuts the section line outside of the map area. Okay, just fold the map and place it in that line. With the help of compass, you can take this. This is the value of 800 feet, this point, and this is the point of 900 feet. This is the point of 9. This is the point of 900 feet, and this is the point of intersecting point of 800 feet. So you can get easily the dip. This is the third dip. Okay, this is the dip for this round shape beds. Okay, this round shape beds are the third, the P beds, and the O beds. Okay, O beds. Okay, with the help of set square and with the help of scale, we can plot it. Okay, go through this. So okay, here I have plotted these two, O and P. Okay, and I have plotted P and O, and this is the line of unconformity. So I am putting the curve line, red curve line, that is the conventional symbol of line of unconformity. Now we have to plot this one, E beds and F beds. I have already identified the direction of the deep of E bed and F bed with the help of strike line of values of the strike line is 700 and 600. So the deep of this E bed and F beds is 700, this from left hand to right hand. So plot this. Okay, you can draw another line. and put it here. With the help of compass you can do this. This is the value of 700 feet, this is the value of 600 feet, this is 700 feet. So obviously this is the fourth angle. Okay, the value, then identify the beds, alignments of beds or position of beds in the section line with the help of scale. This one is the beds, this points is the lower boundary of a bed, this is the lower boundary of e bed, and come to that point. Okay, this is an another beds, this is an, go through this, this is an another beds, just beneath the beds of, beneath the lines of unconformity. So you can, and this is also the triple point junction, this is also the triple point junction, this one is the triple point junction, this one is the triple point junction. Just connect this to identify the position, underlying position of the beds. Okay, and you can identify this one too and plot it in, put it in here. And this is the lower boundary of E bed, this is the lower boundary of F bed, this is the lower boundary of, this is the lower boundary of this beds. Okay, so plot this, plot 3 this, I'll put with the help of set square, with the help of set square you can easily draw the deep of the, you can easily draw the deep of the, this one, this one, this one, and this one. Okay, and go through the map. Okay, go to the map. Okay, I have plotted E, plotted F, and also the layers that is just beneath the layer of line of unconformity. I have plotted the 3 layers, but here the repetition of beds is very common. This beds is repeated in here, this bed is repeated in here, this bed is repeated in here. Obviously it's a beds, it's a map of a folded region. So draw another straight line to identify the direction of the deeps, direction of the beds, direction of the deep of this of the beds of right hand sides. Okay, okay, go for that. Okay, this is a strike line of 700 feet. Okay, 700 feet. Okay, just draw this. This is 700 feet, and these layers, this layer here cut, this is the 700 feet, this is the 700 feet. Okay, you'll go through the another bits. Okay, this is 600 feet. Okay, this is 600 feet, and this one is 700 feet. Okay, just ignore that, this is 700 feet. So obviously deduction is that this is 700 feet, this is 600 feet. So the deduction of this beds, right hand side beds, is this one. Okay, and just plot the diff with the help of, here this is the point of 700 feet and this is the point of 600 feet. The obviously the deep direction will be, this is fifth one. Okay, just put the map along the section line. Okay, this space is repetition of that one, this is the repetition of that one. Okay, so observe carefully, observe carefully. So you have to identify, this is the layers beneath the line of unconformity. So this is just identify the position. So I have superimposed this beds, but this is this is beneath, this is lying the lower part of the line of unconformity. So I have identified that point. Then second one is that point. So, and third one is the outside of the map area. So I have to plot first these two things. With the help of set square you can plot this. With the help of set square with the help of set square, the help of set square, with the help of set square, just identify the proper position, otherwise it's very difficult to plot. Okay, so you have to identify this one and that one, that one, that one, and third one is the outside of the surface area. Okay, so follow the, with the help of set square you can plot this. Okay, so you can take a help of eraser, just remove this, just remove this. Okay, and you can put the ink. Okay, otherwise it's very difficult to identify. This one, this one, this one. With the, I am putting ink because it's very not visible to you, that's why I'm putting ink. Okay, and this one. Okay, so observe carefully, observe very carefully. Okay, okay, here 1 2 and 3, this beds is just beneath the line of unconformity. This is the 1 2 and 3, and those P and O are the beds is above the line of unconformity. This O and P, this is the line of unconformity. Then come to that point. Okay, this one come to that part. This is a one layer, this is underlying layer, the layer lies beneath the line of unconformity. This is F layer, this is also beneath the line of unconformity, and this is another layer just outside of the map area, suppose. Okay, then you have to identify the direction of the beds with the help of this contour of 600 feet and contour of 700 feet, and you have to identify these beds, and these beds, 3 beds. Okay, with the help, just fold your geological map and you have to plot it the angle here and put this and identify the point. This is the point, this is the just beneath the, this is the layer just beneath the line of unconformity, this is the layer just beneath the line of unconformity, and this is the outside of the section area, and you have plotted that. And this one is left hand side and this one is right hand side. Obviously this is left hand and right hand, this is a fold area, that's why both layers is merged here. This is the merging point. This is an F layer, this is also the F layer, this is F layer and this is also the F layer. So both are merging, both are matching that point, and this is a E layer, obviously this will be the A layer. Okay, and both are merging this area. This is the basic thing of plotting the geological map. You have to follow all these things with the along the section line. And here first one is the, I got the information about the landscape, I got the information about the landform. Okay, this is the undulating area. Okay, and the surface runoff. Okay, surface runoff. Okay, think about the surface runoff, go through this map. Okay, if you pour water, then water can moves along the higher value to lower value. Okay, those, and always follow the trough zone, and this is the trough zone. Okay, this kind of zone is known as trough zone. Okay, this is the trough zone, maybe that kind, maybe this. Okay, so value here, the value is 800, 700, 500. So if you pour water, water will moves in that direction. This is the one surface runoff, and go through this. This is also a trough zone, just like a peak zone. Here the value is 1100 feet, here the value is 500 feet. So obviously that is the position of surface runoff. Okay, so on. So here go through this direction. Okay, there here the values is, here the values is 900 feet. Obviously water comes from higher to lower, and this is the, and in that way you can identify the position of surface runoff. So first thing is that from a geological map we can get the idea about the landform. Basically from that map you can identify the landform. Second one is the surface runoff. From that geological map you can identify the surface runoff. Okay, and if you draw a rough sketch of this map, just change this map, just prepare a 3D view, just prepare a 3D view. And suppose if you poured water, water can move that direction to that direction, this direction, and your main river will develops. Okay, just match with this thing. Just make a match. Okay, just make a match. Okay, just make a match for the surface runoff. Okay, this is the main tributaries. That one, this one is the these things, and this comes, tributaries come from the right hand side, this tributary is coming from the right hand side, and this tributary is coming from left hand side, this tributary is coming from left hand side. Just draw the surface runoff, identify the surface runoff on the basis of the contour value and on the basis of the pattern and curvature of the contour value, and plot all these things, and imagine this is a 3D. Imagine this is a 3D, and if you pour water, water will move in that direction. Okay, so that will be perfectly matched. This is second thing is the surface runoff. Now come to the third one, that is the alignment of bed by internal condition. Okay, internal situation about the beds, alignments of beds, all these things. Okay, second thing, suppose this is the O bed, this is P bed. Okay, and this is the P beds. Okay, this is the Q and S beds, this is G beds, this is F beds, E beds, D beds. If you match with this, okay, this is the also the E beds, F beds and G beds. Okay, so go through this. This one is the G beds, this is the G beds, this one is the F beds, this is the F beds, this one is the E beds, this is the E beds, this is P, this is P, this is O. But here this is Q and S. What will be the probable situation? What was the first incident? Here the superficial attributes and the internal condition and their interrelation normally shows the internal history. So take this, just imagine this. So this will be a base, that part is erode. Okay, this is a line of unconformity, this is the line of conformity, this line of unconformity is just above the G bed, this line of unconformity is just above the E bed. So P beds, this is the P beds, this is the line of unconformity. So, and this is Q and S beds. So what is the evolutionary history? What is the history behind this landform? Suppose Q and S, these two beds here lies as a remnant beds, as a residual beds, all are weathered. But P beds, and this is a fold zone, this was a fold zone one of the time, this was the anticlinal zone, and now it become the syncline. Okay, and this alignment is syncline, now it looks like a anticline. This alignment is a synclinal alignment. Okay, and it looks like the outer surface of this areas looks like a anticline, and this outer surface, this topography, if you think about the topographical point of view, this is the synclinal. Okay, this is the anticlinal. From the topographical point of view, this is the anticlinal. But if you identify the relationship with the internal structure, here the internal structure is the synclinal. here the internal structure is the synclinal. So there is an internal structure is the synclinal, outer surface is the anticlinal. So obvious relationship in the internal structure and the outer surface. This topography shows the landscape evolutionary history, that is the inversion of topography. In first same, I think there is a theoretical part, that is inversion of topography. This is the example of inversion of topography. Okay, here the synclinal internal alignment, but the superficial attributes looks like a anticlinal. Here the synclinal alignment in the internal position of the earth or internal structure of the beds, internal alignment of the beds, but the outer surface is anticlinal. Okay, so there is also relationship between the here the there the in synclinal zone. It's like it looks like a synclinal, but in past, in a long time ago, it was the anticlinal zone. That part is removed by the erosion, by the activities of weathering, all these things. So the river has shaped. So the in synclinal valley there is a river system, and anticlinal valleys there is a, this is the anticlinal creased anticlinal zone. So there is an secondary river system comes and join with the primary river system, or this is the subsequent stream. Those are the consequent stream. In Bengali, this is the Onugami Nodi, and those are the Paraborti Nodi. This incident, this geological map shows the inversion of topography, because these are the anticlinal in outer surface, inclinal in synclinally internal structure. So it's not to it interpret the internal situation, landform and surface runoff, and ultimately it depicts the evolutionary history of landscape, and not only the evolutionary history of the landscape, and evolutionary history of the surface runoff. Okay. Okay, sometimes river may shift from the anticlinal ridge to synclinal valley to anticlinal ridge, all these things. And also identify the river history and also the landscape history.